Hello, in this lecture I will try to answer the question, is the universe infinite? The universe is all of space and time and their contents, including planets, stars, galaxies and all other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. According to this theory, space and time emerged together 14.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 93 billion light years in diameter and present at the present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang. So any part of the universe that is more than 14.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but is impossible to say for sure that that is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privileged or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on a large enough scale the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could have a positive curvature, which is like two-dimensional curvature of the surface of a sphere. That is to say, the universe is closed inward and it is finite, and the shape is like a shape of a sphere. The second possibility is zero curvature, which is like a flat plane, and then the universe is not closed but infinite. The third possibility is that the universe has negative curvature, which is like the curvature of the surface of a saddle. Then the universe is not closed at all and it is infinite. If the universe is isotropic and homogeneous and the curvature of the universe has constant positive value, then the universe will be finite, just as the surface of a sphere is finite. On the other hand, if the curvature of the universe is a constant zero, then it will be like the flat plane, or it has constant negative curvature. That is to say, the universe open outwards and never closes. Like the saddle, the universe would be truly infinite. Do we have any measurement of the amount of curvature that the universe has? Yes, there is. The standard model of cosmology, which successfully fits all well-measured cosmological information, as a parameter total omega, which is related to the curvature. So the total omega is actually a number that measures how much the universe, how much it has the curvature, and whether if the curvature is positive or negative. If the curvature is positive, then the universe is closed, and if it is negative or zero, then the universe is open and it is infinite. So if total omega is greater than 1, then the universe is positively curved. So here total omega is greater than 1, and so the universe is positively curved, and it is closed like a sphere. And if total omega is exactly 1, the universe is flat, and it is also infinite. And if the value of total omega is less than 1, like here, the universe is negatively curved and it is infinite. The best measured value is total omega equals to 1 plus minus 0.12. If total omega equals to 1 plus 0.12, that equals to 1.12, that is to say that total omega is greater than 1, then the curvature of the universe is positive, and the universe has a shape of a sphere, and the universe is closed. Yes? So if total omega is greater than 1, then the universe is closed because it has a positive curvature. If total omega equals to 1 0.00 minus 0.12, that equals to 0.88. That is to say, total omega is less than 1. Then the curvature of the universe is negative, and it has a shape of a saddle, and then it is infinite. So if total omega is greater than 1, the universe is closed and it is finite. And if total omega is equals to 1 or less than 1, then the universe is infinite. Okay? So everything is possible from positive to 0 or negative curvature. So there is no definitive answer at this point, but the universe is consistent with having 0 curvature, because total omega is close to 1, because total omega actually equals to 1 plus minus 0.12, so it is very close to 1, and that is the reason that it must be close to flat, because if total omega is exactly 1, then the universe is a flat plane and infinite. So it is close to 1. Yes, so we really, so it must be close to flat, flat plane. So we really don't know if the universe is infinite at this point, but since the value is so close to flat, even if the universe is positively curved and finite, it would definitely be much, much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. At the moment, we don't even know if it is finite or infinite, but there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.